All right, welcome back. Hey, so we just wrote a filter that visits each pixel and converts it to the closest pixel from a palette of 8 colors. Let's do something even more interesting. We're going to use a technique called error propagation dithering, where what we do is we try to mix adjacent pixels together to get a closer color match. So the idea is you visit a pixel, you know what pixel color you want, you pick the closest one, you put it there, and then you remember what the error is. You remember how far off you were so that you can apply that error to the next pixel. And we keep doing that. There's a couple of different ways to do it. We could spread it around to surrounding pixels, but we're just going to do adjacent pixels. And it leads to a neat kind of 80s effect when we do that kind of thing. So this will be our dithering thing. Now to get us there, we need the capability to really work with the differences between pixels. So I guess in this video, we're going to add a pixel delta that we're going to need to use. So let's start there. Let's go to the RGBA pixel. And this is so closely tied to the RGBA pixel, I'm going to keep it in the same class. You could pull it out into its own class, but they're very associated, so I feel good about putting it here. So public, we'll call it's a struct because it's a value type. We'll call it pixel delta, right? So what is a pixel delta? Well, it's something, it's got to be, we want to hold the difference. We want to basically hold, it's like a pixel, but it's signed because it can be positive or negative. So we're going to say the init will take 3 signed values. So we'll take an R delta with the keyboard caps unlocked. Let's see, R delta, and that'll be an int. G delta, that's also an int, and B delta. Surprise, surprise. There we go. Okay, and we want this to be, we're going to store these in our delta, G delta, and don't need those semicolons. B delta. Okay, that's getting us close. In the initializer, we just need to do the obvious things. Okay, that's a good starting point. So it's as simple as that. Now we're going to build on this, but let's see what we need to build on it. I'm going to start our filter. Let's go back to filters. And we're going to be reusing this. I'm going to pull this out right now before I forget. I'm going to take this palette out. It's still a very good name. We just want to put it out there because our dithering filter is going to also use that same palette. So let's create a filter called, what do we want to call it? We want to call it Dither 8 filter. This is Dither 8 colors. And right, so we're going to visit each pixel. We're going to start off like this. We're going to say, we're going to go let delta equals pixel delta 0, 0, 0. And that looks pretty good. Okay, so we start off with a delta of 0. What does that mean? It means that when you start off in the corner of the image, we're going to act as if the previous pixel was 100% correct. We just need a starting value. Okay, so what do we want to do? We want to, oh yes, we need to be able to take a pixel and add, let's see, add ourselves to the delta, right? So let's start writing this, and it'll maybe make sense. So we've got our pixel P. Okay. We need to let's see, what do we want to do? We want to be able to find the closest match. But we don't want to find the closest match for the pixel P. We want to find the closest match for the pixel P plus the delta. Okay? So, I'm just going to say, I'm going to start writing this. Let new delta equals delta dot add P. So we want to be able to add a pixel, okay, to a delta. Let's go back to our RGBA pixel. And I don't know if this is making sense to you, but it is to me. So let's see. One thing to note, this is an immutable data structure right now. We're not allowing you to change the deltas, and I do like immutable data structures, so let's stick with that. Our function called add is going to take an RGBA pixel. We're going to call it the added pixel. And it's going to return a pixel delta. So how do we do this? Well, we just return pixel delta. The R delta is, what is the R delta? The R delta is the current R delta plus the pixels red. Our G delta. And we'll do the same thing for the G channel. And we'll do the same thing for the blue channel. Oh, and this is a func. And is it complaining about R delta? Use of identifier pixel delta. Oh, capital P. Use of unresolved identifier. Well, that's because I called it add pixel here. I'm going to call it P. Yeah. Nice. Okay. And now it's probably yeah, I thought it might do that. Okay, so we need to upcat this to an int. Same here. Oops, cap blocks was on. And lastly here. Okay, that should just about do it. Right. let's go back to our function. Okay, so we were able to add a pixel to our delta, right? Now, the next thing we want to do, so this delta includes the contribution of 2 pixels, right? We do need to be able to go to the delta, and we want to be able to get the closest pixel. So let's go func closest pixel. As a matter of fact, we could just say as pixel, right? Okay, so here's an interesting function. It needs to, we have the RGBA, and they may be out of range. Okay, so I'm sorry. We have the R delta, the G delta, and the B delta, and they may or may not be in range. So I'm also going to create a helper method called func. Let's see, we want to limit the range. Sure. As a matter of fact, we're capping the range. So yes, let's go. This will be RG color channel. Okay, so we're going to be passing in something like an int. Yes, we're going to be passing in an int and returning a uint 8. That sounds right. Limit range. Actually, I'm going to say limit to legal color channel range. I know that's kind of long, but that's what we're doing. So this is actually the delta. Okay, so what do we need to do? Well, we need to do a few things. We need to limit the range to 0 to 256. So, well, the easiest thing I think is if delta is less than 0, then we return 0. Else, if delta is greater than 0xff, then we return, surprise, surprise. And then finally, else, we just return delta. Cast to a uint 8. Okay, that looks good. Why did we do all that? Well, it's so that we could just do the following. We can return an RGBA pixel, where the red is limited, and I'm going to break this up into multiple lines. It's actually pretty easy to read if we do that. And this is the green channel and the blue channel. Not bad at all. So what have we done? We have an RGB delta. This just limits the range for us. It limits, if it's less than, yeah, you get the idea. Let's go back to our filters. So now we can start getting ready to do our dithering. And you know what? I'm going to stop the video here and pick it up in the next video because it's getting kind of long, okay? All right. Thanks, guys.